Hello, in this video I'm going to describe the codes in STM32Cube IDE. But first of all, I need to mention that you need to know about the USB library and crypto library, which all of them as described in the ST's YouTube channel MOOC. However, in the USB-D custom HID if.c file, I can receive the all packets which I receive from USB ports. I copied the receive packet in the USB packet command in buffer array, then perform a manage message. As a result of manage message function, if we are in sending status, if we should send ACK, then it copied this buffer to the output buffer and send it to the host, which means it is ACK. But if we are in the response mode, we should transfer data to the host. We should transfer response to the host, which we have propertied or put it in the command output buffer in the main file. Manage message, as I said before, is considered for managing the message. It indicates which kind of packet is this. If it is a packet number 0, number 2, 3, 4, 5, or 6, 7, 8, 9, or 8, which I have described here, this packet. Based on the type of the packet, it performs different duties. For example, for the message from 1 to 5, we try to copy the input buffer to the encrypted message. If it is the number 5, fifth part of the message, it's try to clear the buffer 2, let the output buffer 2 for the next operation. If it is number 6 to number 8, so it means that is the ACK it received, so it try to send the next part of the response. For example, if it receives 6, it means that it is the ACK of the first part of response, so it sends the second part. If it is 7, it means that it is the ACK of the second part of the response, so it sends the third part of the response, and until the 8. After finishing this, then we receive the last acknowledge of the 5th package. Global status is passed, and it goes to the wait for the request. Okay. And I designed for, and I have a code for the send first part response, second part response, which create this kind of operation. Make this kind of packets for sending. I described in the previous video. And the response, both part of the response. Also, there is a state machine, which I said in the first video. There is no need to do anything in the wait for request or response request, but in the process request, it should decrypt the message, check the validity of the message, and encrypt and send the first part of the response. And in the check validity, it compare the application ID, which is stored in this MCU, and the received message from the USB. If it's okay, it try to get another part of the it check this part. If it's okay, then it try to extract this random number with this code. It is a simple shift from the beginning to the to the beginning of the array. And I used this state machine here in the while of the my MCU. In the while of my MCU, I have used this state machine. For decrypting and encrypting, for decrypting message and encrypting response, which I mentioned, for encrypting, we can use for decrypting. I use the module and private exponent of the device, and I decrypt it and perform some other operation to normalize it. And for encrypt, I use the module of host and public exponent of host or Windows application at the key or Windows application to encrypt and this code.